Imagine a world where the vast, frozen Arctic isn't just thawing, but is actively being drained. A place where nations are literally racing against time, pouring trillions of dollars into a project so ambitious, it sounds like science fiction. What if humanity's desperate attempt to reverse climate change involved reshaping the very top of our planet with consequences no one can truly predict? The Arctic's fatal feedback loop. The problem is no longer just rising temperatures, it is the Arctic amplification effect. This is a deadly cycle fueled by one simple physical property: color. When sunlight hits bright white sea ice, up to 90% is reflected back into space. This is the albedo effect. But as that ice melts, it exposes the dark blue ocean water beneath, which absorbs up to 90% of the sunlight, heating the water further and accelerating even more melt. It's a runaway train with no brakes, and humanity is currently trapped in the observation car. The true tipping point, however, lies in the permafrost. Vast swaths of Siberia, Alaska, and Canada are currently held together by frozen ground that contains a ticking carbon bomb. As the Arctic thaws, this permafrost begins to decompose, releasing not just carbon dioxide, but enormous volumes of methane, a greenhouse gas up to 80 times more potent than CO2 over a 20-year period. This injection of methane into the atmosphere is the catastrophic event many scientists fear the most, a point of no return that guarantees extreme, irreversible planetary change, regardless of any future emissions cuts. The stakes are clear. If the Arctic goes, it takes our comfortable, climate-stable world with it. The immediate consequence is visible in the rising oceans. Current projections show coastal regions facing existential threats: Shanghai, Mumbai, New York, and the entirety of low-lying nations like Bangladesh and the Netherlands face catastrophic inundation this century. We are staring down the barrel of a mass migration crisis involving hundreds of millions of people, collapsing global economies, and perpetual humanitarian disasters. This is the hellscape the proponents of Arctic drainage seek to prevent. They argue that if the natural mechanisms of planetary temperature regulation are broken, humanity must build new ones. The audacity of giants. The notion of remaking the map is not new. In the 1,920 seconds, the German architect Hermann Sergel proposed Atlantropa, an insane, yet technically detailed plan to dam the Strait of Gibraltar and partially drain the Mediterranean Sea to create millions of square miles of new farmland. While Atlantropa was abandoned due to its geopolitical absurdity and environmental risk, the scale of that thinking, the idea that humanity could intervene on a continental level, never truly died. In the modern context, the focus has shifted to climate intervention, or geoengineering. The concept of draining the Arctic stems from the most extreme wing of this research, which views incremental policy change as a failure and radical technological fixes as the only viable escape route. The core premise is simple: reduce the volume of meltwater in the Arctic Ocean, stabilize its internal pressure and salinity, and allow the massive 2-mile thick sheets of ancient ice to refreeze and restore the critical albedo layer. This is not about building a seawall. It's about building an ice factory powered by a hydrological reverse flow system. It is the ultimate expression of human audacity. Engineering the impossible. So, how exactly does one move trillions of gallons of water from the top of the world? We are talking about a multi-trillion-dollar logistical and engineering challenge that stretches the limits of materials science and mechanical power. The most viable and yet most frightening proposal involves a system of subarctic deflection tunnels. These would be a network of colossal bores, approximately 50 meters in diameter, drilled deep beneath the permafrost, running thousands of miles from the Arctic Ocean basin south toward the Pacific. The tunnels would utilize massive, continuously operating magnetohydrodynamic pumps machines that use powerful magnetic fields rather than moving parts to push seawater, allowing for the movement of colossal volumes of water without the friction and mechanical stress of traditional machinery. Imagine the engineering footprint. Thousands of remote, highly automated drilling rigs specialized robotic tunnel boring machines operating deep beneath the Siberian plateau, and the construction of immense fortified coastal outfalls to manage the resulting surge of frigid water into the Pacific. The energy demands would be astronomical, likely requiring the construction of entirely new fleets of fusion reactors or vast, dedicated solar fields just to power the pumping operation. The estimated material requirement for concrete and steel alone is calculated to exceed all global production for an entire decade. A less invasive, though equally risky, approach involves atmospheric manipulation and aerosol seeding. Instead of draining the water, this proposes using high-altitude aircraft to spray reflective sulfate aerosols into the stratosphere above the Arctic. The goal is to create an artificial solar screen, dramatically reducing the amount of sunlight reaching the ice and causing a rapid, localized cooling effect. While cheaper, this method is highly unpredictable, essentially holding the global climate hostage with a gigantic atmospheric dimmer switch that could lead to unforeseen consequences far from the Arctic Circle. Success would mean stabilizing sea levels, protecting up to 20% of the world's population living in low-lying coastal areas, but there are also hidden massive geopolitical gains. The successful stabilization of the Arctic would secure permanent access to the northern sea route, the shortest shipping lane between Europe and Asia. Furthermore, the newly stable region would open up vast, currently inaccessible deposits of oil, natural gas, and rare earth minerals, turning the Arctic into the 21st century's most contested economic zone. For the nations that bear the financial and engineering burden of this project, the reward is not just survival, but unprecedented global resource dominance. The global climate gamble. Interfering with the Arctic Ocean is the ultimate climate gamble. The Arctic is the cold engine that drives Earth's global climate system, particularly the Atlantic meridional overturning circulation, which includes the Gulf Stream. The AMOC acts as the ocean's planetary conveyor belt, pulling warm, salty water north toward Europe and carrying cold, dense water south. The Draining the Arctic project, by rapidly redirecting vast quantities of cold, fresh meltwater into the Atlantic or Pacific, risks injecting a massive cold shock into the system. This infusion of cold, less dense fresh water could slow or even collapse the AMOC, a change that would plunge Western Europe into a new, rapid mini-ice age within decades, completely overriding the benefits of any global warming mitigation. We would be trading one disaster for two. Beyond Europe, the risks are profound. Rapidly shifting ocean currents would reorganize global rainfall patterns, potentially creating vast desertification bands across the Amazon or the American Midwest. Furthermore, the sheer political and legal complexity is paralyzing. This is a project that crosses the territories of Russia, the US, Canada, and multiple Scandinavian nations. An international effort of this magnitude would require unprecedented, unified governance, and the question of liability for an inevitable catastrophic failure would be unanswerable, potentially sparking global conflicts. The trillion price tag is likely conservative. It covers materials, energy infrastructure, and 20 years of continuous operation. But it doesn't account for the geopolitical maneuvering, the potential lawsuits from every fishing community affected by cold-shocked water, or the sheer political will required to sustain this burden across multiple global economic crises. Ultimately, the Draining the Arctic project serves as a stark metaphor for the desperate state of our planet. It forces a critical decision. Do we accept the profound risks of playing God with a planetary system in an attempt to buy time, or do we double down on immediate, fundamental decarbonization efforts?